All right. All right. I want to. Let me run through the first page. Is that cool? So, some of the questions that I'm going to go over, I'm going to use this also as a review time. It didn't necessarily ask for it on this as directions, but it'll help you out. So let's see. Problem number 1, we have paste. All right. Is this one, what value up there am I missing? A, B, or C?
B.
B? Everyone feel comfortable with that?
Yes.
If B is gone, and I use the equation x equals negative b over 2a, if b is the numerator, or the top, what does that have to give us for an answer? So if our b value is missing, and it's 0, that means the vertex, the x component of my vertex is 0 comma something. That means my axis of symmetry has to be x equals 0. Okay? Make sense? All right. Now, here I have a question. If I have the x component of the vertex being 0, how do I find the y component of the vertex? Yeah, plug 0 right on in. So you get 0 squared minus 2. 0 squared is 0. So I get negative 2. So 0, negative 2 is down here. Hey, what did I just find?
Your y-intercept.
Y-intercept, and the y-intercept can be the same thing as the vertex, right? So that's my vertex. It's also my y-intercept. Okay? All right. Can I pattern graph with 1, 3, 5?
Yes.
Sure can. I don't have to change any values because my lead coefficient here is 1. Okay? So I'm going to go right 1, up 1, left 1, up 1, right 1, up 3, left 1, up 3. Okay. Does this have roots? It does.
But you can't see them.
Yeah, so that root there, I would put this for an answer. Question mark, comma, 0. For this root right here, I would also put question mark, comma, 0. Okay? What do you think that tells me that you know? If you put
there are roots, but we don't know what they are.
Exactly. Okay? So we're going to see this sometimes come up where it's like, okay, you have question mark, comma, 0, question mark, comma, 0. That says that I understand that it does cross the x-axis. I just don't know exactly where it crosses at this point. Okay? Hey, I'm just going to throw this question out there. Where is this graph increasing? Increasing means it's going up.
Negative 2 to infinity.
0 to infinity. So it starts here and it goes forever this way. So it's this whole part of the graph right there. Okay? 0 to infinity is where it's increasing. It's decreasing.
Negative infinity to 0.
There you go. Negative infinity to 0. Exactly. Increasing. Okay, so that's just extra information. You might have to watch over that later. Can I do number 2? Ready? So problem number 2, they've given us as y equals x plus 2 in parentheses. Quantity squared. That's it, right? Yep. This particular problem is set up in vertex form. This one's set up in vertex form. Vertex form, you recall, is this, where my vertex is opposite grouped, same knot. Okay? So my lead coefficient outside my A value on this one's 1, do you agree? But I'm missing what value?
K.
The K. So if it's missing, it must be what? 0. So there's a 0 over here. So what's my vertex?
Negative 2, 0.
Negative 2, 0. What's my axis of symmetry?
Negative 2, 0. Wait, negative 2.
Huh? Ooh, what?
X equals negative 2.
X equals negative 2. Do we have enough information to start graphing this bad boy?
Sure do.
Yep. So negative 2, 0. It's right there. Does my pattern graphing start working with 1, 3, 5? Sure does. Right one up 1, left one up 1, right one up 3. Hey, what did I just find? On the y-intercept. Okay, so that happens to be my y-intercept, which is 0, comma 4. Agree? Okay. Roots, what do you know? Huh?
No, it's at the vertex.
At the vertex.
The vertex and the roots happen to be the same. So my roots, I only have one. I guess I have a root. My root happens to be negative 2, comma 0, which in this case happens to be the exact same thing as my vertex. Okay, so sometimes that might happen. Hey, where is this graph negative? What does it mean if I say it's negative?
Where is it?
Where does the negative values in the y direction occur? Above or below the x-axis? Below. Where does this graph exist below the x-axis? It doesn't. So where is this graph negative? You would actually give our fancy empty set sign. Okay? Now, the big trick question on this is if I were to say, hey, where's this whole graph positive? Is the entire graph positive? No, the vertex is actually 0. 0 is not positive or negative. But I won't throw a gotcha question at you like that. May I go to number 3? Y is equal to x minus 3 quantity squared. There's an x right there. Plus 2. All right. Is this set up in vertex form?
No. Yeah, it is.
It is. So what's my vertex?
3, 2. 3, comma 2.
3, comma 2. What's my axis of symmetry?
3.
Almost.
X
X equals 3. Don't forget the x equals. You'll lose a point you do that. Okay, there's vertex axis symmetry. So 3, 2. 3 up 2. Can I pattern graph with 1, 3, 5?
Yes.
Sure can. I don't have to modify it. So 1, 3, 5 will work. So I go right one up 1, left one up 1, right one up 3, left one up 3. Okay, so let's figure out the y-intercept here. Right? Let's hit the y-intercept right now. So the y-intercept, has it presented itself on our grid? Everyone agree with that? That makes sense? So the y-intercept is always 0, comma, something. This 0 is a what value? It's an x value. What do you think I should do with that x value to figure out the y value? Yeah, plug it in. So if I plug 0 in right there, I'm going to get y is equal to 0 minus 3 quantity squared plus 2, which is negative 3 quantity squared plus 2. What's negative 3 squared? It's 9. So then I get 9 plus 2, so I get to 11. My y-intercept is at 0, comma 11. Does this appear that it could have worked that way?
Yep.
Pretty close. Roots. What do you mean? Roots. They're complex. Hey, why am I not putting question mark, comma 0, question mark, comma 0? There are not roots that cross the x-axis. If you do the question mark, comma 0, question mark, comma 0, that just means you can't tell exactly where it crosses the x-axis. This graph does not cross the x-axis, so the roots happen to be complex. Okay, part of the complex number system. Hey, where is this graph positive? You have to use the X to identify it.
Oh,
It's the entire graph. So if I go forever that way in the X direction, so I get to negative infinity, no matter what negative number I plug in, my result will result in me getting an answer that's positive. Same thing this way. If I plug any positive X value in, my result for Y will always be positive. So this entire graph is positive. Where is this graph decreasing? Where is it going down?
negative infinity to 3.
Negative infinity to 3. Awesome. So it's right here. That's the decreasing part. Okay? Good stuff. Good stuff. Number 4. Number 4, we have y equals. Is this one set up in vertex form? Sure is. So it's set up in vertex form as well. Okay. So what's my vertex?
485.
Vertex is 4, -5. What's my axis of symmetry? X equals 4. Good. Okay. So 4, -5. 1, 2, 3, 4. 1, 2, 3, 4, 5. Can I pattern graph with 1, 3, 5? I can. My lead coefficient's 1, so 1, 3, 5 is going to pattern graph for us nicely. So I'm going to go right 1 up 1, left 1 up 1, right 1 up 3, left 1 up 3. I even go right 1 up 5. 1, 2, 3, 4, 5. Left 1 up 5. Ooh. I almost got close to where across the y-axis, but we don't know yet. Okay. So let's answer this question real quick. Roots. That's bad color. Roots. What? I heard it. Question mark, comma, 0. Question mark, comma, 0, and question mark, comma, 0. Again, what does that tell us? That tells us that we know that it crosses the x-axis, but we don't have the exact answer at this point. Is that all right? Got the vertex. Ooh, y-intercept is definitely going to cross the y-intercept, but how do I find where it crosses the y-intercept? Plug in 0 for what letter? X. So 0, comma, blank. So if I plug 0 in, I'm going to get 0 minus 4, quantity squared, minus 5. 0 minus 4 is -4. What's -4 squared? 16. So I get 16 minus 5, which is 11. Does that appear it could be crossing at 11? Where is this graph increasing?
Oh, and does that mean going up or sideways?
Going up.
From where's the?
Here's a vertex.
4 to infinity.
4 to infinity. That's it. That's where it's increasing.
For sure, if I walk out there and it's going chaotic.
With me?
Some girl got like really hurt, and like the radios are just going crazy. There's like 3 different situations.
That's awesome. Let's go get brownies. Yes. Number 5. Number 5. Number 5. Well, I'm sorry for that young lady. I hope everything's fine. Is this one set up in vertex form?
Yeah.
Sure is. Which value am I missing?
Okay.
Okay. So if it's missing, it must be what? 0. Good. Okay, so what's my vertex in this case? -1, comma, 0. What's my axis of symmetry?
Symmetry is x equals -1, sir.
Yep. Hey, what did I just find by plotting the vertex?
Root.
I found a root. Is it okay if the root and the vertex are shared?
Yeah.
Sure. Hey, does my 1, 3, 5 work here?
Yeah, no.
No. What should I do?
3, 9, 15.
3, 9, 15. So we might not have enough room to do with the 9, but we'll deal with it. How'd you do? So if you did really cruddy on this, you do well on tomorrow's, you're going to knock it out of the park, okay? All right. 3, 9, 15. Ready? Write one up. 1, 2, 3. Hey, what did I find?
Y-intercept.
Found the y-intercept. The 9 is not going to fit, so I'm just going to plot with what I have. Okay. Y-intercept happens to be 0, comma 1, 2, 3. My root happens to be the same thing as the vertex, negative 1, comma 0. What'd I do?
Teach them math.
Who?
People.
All right. Shh. Anything else? I think we're good there. Can I go to number 6?
Yes.
All right. Number 6. This will be the last one, or I'll do the whole back page too. Y equals negative 2 quantity x, x minus 3 squared plus 5. All righty. Paste. Vertex.
3,
3, 5. Axis symmetry.
X equals 3.
3, 5. 1, 2, 3. 1, 2, 3, 4, 5. Okay. Does 1, 3, 5 work on this one?
No.
No. What is the one?
Negative 2, negative 6, negative
Right.
2.
So negative 2, negative 6, negative 10. I love it. All right. So right one down 2. Left one down 2. Right one down 6.
We found roots.
But they are question marks. Okay, and I couldn't get the negative 10 in there just because it'll be off our screen. So let's take care of our roots. Those roots are both what?
Question mark 0.
So question mark comma 0 and question mark comma 0. Why do I list it twice?
Because there's 2 of them.
Because there's 2 of them. Good. You guys are following my rhyme and reason. Question, how do we find that y-intercept?
You plug in 0.
Yeah, so I get 0, comma something. So I'm going to plug 0 in. So I get negative 2 times 0 minus 3 squared plus 5, which is negative 2 times negative 3 quantity squared plus 5. What's negative 3 squared? 9. What's 9 times negative 2?
Negative 18.
Negative 18,
Plus
negative
5 is
negative 13. So yeah, that could have happened, I guess. Hey, where is this graph increasing? Negative infinity to through 3. Awesome. So it's increasing all right here. This whole region here is increasing, okay? Cool. All right. Let's go to that back side. All right, for all of these, we're using this equation where we know the vertex is opposite here, same here as far as the sign goes. Okay? So it looks like on this first one, 3, 1.
Are these the graphs that don't have equations to them?
Yeah.
Oh, I know the first one.
All right. So the A value dictates our pattern graphing. Agreed? So our first problem we have y is equal to, does the pattern graph work with right one, up one?
Yeah.
So what's my A value? 1. And then what's my vertex? X minus, so my vertex is at, what is that, 3, 1?
X minus 3.
So x minus 3, so it's always opposite inside and plus 1. So that's my entire equation. Hey, what does this tell me right here if you put that 1?
No, it's just your,
The pattern graphing is perfect, right?
Perfecto.
Alright, next problem, this one over here. So it looks like my vertex is at what, negative 3, 4, is that right? Okay, so if I pattern graph, does right 1 or 1, 3, 5 work? My pattern graph on this one, does 1, 3, 5 work?
1, 3, 5. No,
No,
it's negative 2.
It's negative, and it's negative what?
216.
Negative 2. Okay?
I called it.
Then you have x plus 3, because it's opposite squared, plus 4. Oh, squeeze in there. Yay. Okay? So again, because the pattern graph went right 1 down 2, that means that my A value has to be a negative 2.
Yeah.
All right, let's see. This has a vertex at negative 1, 2, 3. Is that negative 4, 1? Or negative 4, negative 1? All right. When you look at it, does it go right 1, up 1?
Yes.
Okay, so my A value has to be 1. And then x plus 4. Why is it plus 4?
Because you switch it.
It's always opposite, and then minus 1. There you go. And then last one. Looks like my vertex is at 1, 2, 3. Is that up 7? 3, 7. Is that right? All right, does my pattern graphing work with right 1 up, or 1, 3, 5?
Negative 2, 6.
Yeah, so we got a negative. So I got y equals negative 2 x plus 3 or minus 3? Minus 3 plus 7. Done. That's it. Yeah.
Sorry, why do you square? Why do you put the 2 exponents?
This one?
Yeah.
It's automatically there.
He wants to know his purpose.
Alright.
I'll teach you how to complete the square after you know the unit. It kind of pops out. Yeah.
You have to like y equals 1 or you just put like y. It took my writing utensil so I can.
But if it's supposed to be a negative 2, you don't put the negative 2.
Yeah.
All right. Make sure your names are on that page. That's page 95, 96. Page 95, 96. Hand that in. That's the only thing I want right now.
They took my writing utensil so I cannot participate in school events.
I'm sorry, Nate. He's such a bully. Next thing you know, he's gonna be playing with matches, throwing rocks at cars.
Alright, throw it.
I know. I'm sorry. I messed up.
How do you do that? How do you do it? What am I doing?
All right. Would you please get out page 97? Page 97. Page 97, 98. And I'll be able to get through the front page, and I think that'll be pretty good for y'all, okay? So I'm on page 97, 98. Still with me?
Yeah.
Sweet. Yeah. All right. Number 1, we have I'm going to have y equals, but they have it at f at x. All right. What form is this one presented to us in? Is it vertex? Sure?
It is.
It is vertex form. What's my vertex?
Plus 2 plus 3.
Axis symmetry?
2.
Okay. So 2, 3. Pattern graph work for us?
Yes.
Right 1 up 1, left 1 up 1, right 1 up 3, left 1 up 3. What did I just find right there? Y-intercept, good.
Complex roots.
Complex roots, I like it.
That means the roots, right?
Huh?
Complex roots.
It will not cross the x-axis. And then 0,7 is my positive 7, my y-intercept. All right. Hey, quick question. Where is this graph positive?
I got it. All of it.
All of it. So negative to positive infinity. Good. Where is this graph decreasing?
Negative infinity to 2.
2. Good. So remember, decreasing means right here. It's coming down. Okay? Let's move to the second problem. We good? Okay, is the second problem presented in vertex form?
No, but it finds your roots.
It is not, but it's set up so we can find the roots. Awesome. Okay? What do you mean it's set up to find the roots? Well, my roots are going to be this. I mean, this is the math that's taking place. So you get 6, 0, and 2, 0. Those are my roots, so those are my roots, definitely.
It's in the middle.
Halfway in the middle is our axis of symmetry. So what's right in the middle of these? So that's 4. Is that halfway?
Yes.
What number is that? 1, 2, 3, 4. So our axis of symmetry is going to be at x equals 4. Agreed?
Yeah.
My vertex is going to be at 4, something. How do I find out the something?
Plug it in.
Plug it in. So I'm going to take this here. I'm going to plug it in here and here. So I get 4 minus 6 and 4 minus 2. 4 minus 6 is negative 2. 4 plus 2 is 2. That's going to be negative 4. So 4, 1, 2, 3. Ooh, can you count down?
Yes.
Why can you count down? Why would your pattern graphing work on this one?
Because you don't have to it's not multiply.
Yeah. So you count down 1, 2, 3, right 1. Count down 1, right 1. Perfect. So good for you for seeing that. Here's this graph. I definitely know what roots are. Hey, where is it going to cross the y-intercept? Where does it cross the y-intercept? So at 0, what? Where do I plug that 0 in? You're absolutely right, though.
Plug that 0 into the equation.
So if I go 0 minus 6, 0 minus 6 is minus 6, yes? And 0 minus 2 is negative 2. So what's negative 6 times negative 2? Positive 12. Cool. Where is this graph negative? Where is it negative? Not everywhere. This is negative right here. Where is it negative? 2 to 6. And 2 to 6 is not a point. That's the interval in which it happens to be negative. So between 2 and 6 in the x gives me, if I plug in any numbers between 2 and 6, I'm going to get a negative y value. That's what it means. If it asks for positive, then it would be negative infinity to 2, 6 to infinity. Yeah?
Why, when we're talking about, I don't know if you just answered this, but when we're talking about positive, then we have like 2 things, but then when we're talking about negative, it's just a point.
Well, this is not a point. This is the
It's
interval.
just like,
It's the interval between this. If I wanted to talk about positive, if I didn't want to do positive, it goes from negative infinity, so coming from this way all the way to the 2, and then from 6 to infinity. And the reason that works is this whole region here and this whole region here are above the x-axis. If this flips upside down, that's going to change. If the parabola is upside down, it's possible that you only have one region that would be positive and 2 regions that would be negative. Okay? Problem number 3. You doing okay on time?
Somewhat.
Okay. This one is not presented in vertex form. This is also not presented in intercept form, where we can find where it crosses the x-axis. Agreed?
Yeah.
Okay, so
That is what's that one thing called? B2 minus.
almost. So I'm going to use x equals negative b over 2a. I have to know that my a value is 1, my b value is negative 6, and my c value is 8. So I'm going to plug in x equals negative 6 over 2 times 1. Shh. So I get negative 6 over 2. So I have an x equals negative 3. That's my axis of symmetry. My vertex is going to be at negative 3 comma something. Okay? Negative 3 comma something.
Wouldn't 6 be a positive?
Can you factor this one?
Oh, it is positive. Negative. Positive. Positive. Thank you. Thank you. I didn't get too far. Whew, saved us. All right. So it's positive 3. So how do I figure out the y component?
Plug it in.
Yep, plugging it in. So 3 squared minus 6 times 3 plus 8. So I get 9 minus 18 plus 8. 9 and 8 is 17. Negative 18 plus 17 is negative 1. So 1, 2, 3, negative 1. Hey, does pattern graphing work on this one? Right one, up one?
We could factor this too, right?
It would have factored, absolutely.
I thought you was going dumb. I'm sorry.
What do you got? All right.
Like, all of the
0, comma 8 is my y-intercept. Is that a root? Is that a root? Talking to my wife again. No one's listening. Is that another root? There it is. So sometimes it's in vertex form, it's presenting it nicely to you. Sometimes it might be in factored form, which means you can find where it crosses the x and the y, or the x-axis. And sometimes you have to use negative b over 2a in order to get the answer. Can I move on?
Yes.
We good?
Yes.
Paste. 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 All right. This is number 4. Number 5. Let me get these done, then we get out of here. And number 6. All right, ready? So this has a vertex at 1, comma 0 because that, yes. Pattern graphing is all going to go down. That works there. I'm just graphing them real quick. The reason I have a pattern graph down is because I have a negative out front. This one has a vertex at 1, comma negative 5. Agree? Pattern graph. How do I pattern graph?
2, 6, 10.
2, 6, 10 on this one, right? So right one up 2, left one up 2. Find the y-intercept. Right one up 6. Cool? And I'm just graphing these real quick. This one is set up to where I need to find my roots. So I have the roots at 2, comma 0 and negative 2, comma 0. Agree? So 2, comma 0, negative 2, comma 0. Halfway in between those is my axis of symmetry, which happens in this case to be x equals 0. So my vertex is going to be 0, comma something. Plug 0 in. 0 plus 2 is 2. 0 minus 2 is negative 2. 2 times negative 2, negative 4. Okay. So 0, negative 4. 2, 3. So ladies and gentlemen, this would have been what the assignment was for last night. I would say I'm going to collect page 97 and page 98 first thing tomorrow. We do have a quiz. Guys and girls, when I talked about things are positive, things are negative, you might see that on the quiz. You're going to have this vertex form. You're going to have all the other forms. We got oh, you did? Oh, shoot. Sorry about that.
Look at the girl. So we're gonna walk up and walk past the sack.
Just stare at her.
Wheelchair stretcher.
We do know, she like wants to get you. Okay.
Passed out in her pedal floor. And I guess they think she has no